Good afternoon, ladies and gentlemen. Welcome to AP Statistics. My name is Mr. Royce. I will be your instructor for today. Let's take a look at section 8.8. Those of you who are watching on YouTube, I'm posting the master copies of the note-taking documents for 8.8, 8.9, and 8.10, which are the three documents we're looking at today. So, first of all, 8.8, we have a warm-up. And what did you come up with? Rachel, do you have the interpretation of the p-value here? Yeah, okay, so were you here when I taught the interpretations of p-values?
I don't think so.
Okay, so Paige, do you have the interpretation of the p-value?
I think I have part of it.
Okay, yeah, go with the part that you have.
The probability is 0.0548.
Oh, that's right, of course, Rachel, you're absent. We're gonna get caught up on this. So in some ways, this is a good thing because this gets you caught up on some of the stuff you missed. So the probability is 0.0548 that we what? Observe. And by the way, another thing, I know we've talked a lot about the word observe, that's the eyeball word. This also presupposes that our eyeballs, our senses, are capable of detecting truth. Philosophically, some people these days figure there's no point in observing because we are not in touch with reality and what we sense is not true. But the scientific method presupposes that what we observe is evidence by which we can draw conclusions that are true, that the senses that we have been given are reliable, at least in community. So keep going, the probability that we observe what, Paige, back to you.
The rate of dogs who bite people of 0.16 is less. I don't know, that's kind of where I stopped.
That's or lower.
Or low.
Okay, so for those of you who are absent, what's going on here is that the null hypothesis is that 25% of dogs bite people. So here's a picture behind what's going on. We observed only 16% of the dogs in our sample. So this is p sub 0 is 0.25, p hat is 0.16, and paper notes are up here in front. And so when we shade left, that's connected to the phrase or lower. So the p-value, by the way, which is the area of the shaded region, 0.0548, Paige is interpreting this for us. It's the probability that we observe a rate of dogs who bite people of 0.16 or less. Who can help me with these blanks on the interpretation? Okay, Jeffrey.
Due to natural sampling variation alone in samples of the same size.
Due to natural sampling variation alone. The word alone is required because there's always going to be natural sampling variation from sample to sample. But we're saying, look, the only thing that's operating here is chance. And the thing that's certainly not operating here is that the true proportion of dogs who bite people is something less than 0.25. It's like, no, it's not that. It's just chance alone, natural sampling variation alone in samples of the same size. In samples of the same size. Now this next word is profound because it speaks to the fact that probabilities are based on assumptions. I mean, think about it. The probability that two towers went down on September 11th, given that the only thing that was operating was natural sampling variation, just like we take a day. It's like with no terrorists involved. The probability that two planes are hit two towers, given that there's no attacks going on, is very low. But the probability that two planes hit two towers, given that we're in a war, is not very low. Which one would we rather believe? As scientists, we'd rather believe the hypothesis that leads to high probabilities, not low probabilities. So the probability is only 5 out of 100 that we would observe a rate of dogs biting people this low or lower just by chance, given that the true proportion of dogs who bite people is 0.25. So if, however, the true proportion of dogs who bite people is really 0.17, then this wouldn't be very unlikely at all. It would have a high probability associated with it, and we'd be, so basically we have to decide whether to reject or fail to reject the null hypothesis. And Rachel, since you weren't here, the idea is that in this statement here is always the null hypothesis. What's the probability that we observe the evidence that we observed, given that the null hypothesis is true? If it's too low, we're going to reject the null hypothesis. If it's not very low, then we're going to fail to reject the null hypothesis. So we're interpreting the p-value. Now, the new material for today, type 1 error is alpha. Type 1 error, by definition, is the probability of incorrectly rejecting the null hypothesis. So we're going to talk about people going to prison. And the racism issue that comes up has to do with African Americans going to prison, and sometimes people wonder about what's going on with that, especially in the case of O.J. Simpson. So we're going to watch a video clip of the O.J. Simpson verdict as it played out in, was like 1995. Probably before you were born. But for me, it was like, that's back, basically it's before the internet, and everyone was watching this on TV. The world was together watching the verdict on TV because the trial had been going all summer. And this was a big deal. It's one of the last widespread big deals on the planet. You're gonna see the global reaction to what happens. Because some people thought an error had been made. So we're gonna try to watch that video clip and figure out, was it a type 1 error or a type 2 error? Now, the null hypothesis in United States courts is that the accused is not guilty. The accused, and O.J. Simpson was accused of murdering his ex-wife, Nicole Brown Simpson. The accused is not guilty, is the null hypothesis. The alternate hypothesis is the accused is not guilty, which means the accused is guilty. So in this country, we give people, in theory, the way it's set up is that you give people the benefit of the doubt. You say, we're going to assume you're not guilty unless we gather enough evidence that leads to a p-value calculation that's so low that we end up rejecting the null hypothesis. So the lower the p-value, that means the more evidence that we have, we're going to reject the null hypothesis and conclude that the accused is guilty. So what is the emotional feel of a type 1 error? If you incorrectly reject the null hypothesis is not guilty. If you reject the null hypothesis, that means the conclusion is that you are guilty. And if that's a mistake, if it was incorrect to conclude that the alternate hypothesis is true, then that's sending innocent people to prison. That's the emotional feel of a type 1 error. A type 1 error is when we make the mistake of sending innocent people to prison. A type 2 error is when you incorrectly fail to reject the null hypothesis. Those are the only 2 errors you can make. You either incorrectly reject or incorrectly fail to reject. We never accept the null hypothesis, so we can never incorrectly accept the null hypothesis. No, it's either reject or fail to reject. What's the feel of this? We failed to reject the null hypothesis, but it was a mistake. So we concluded that basically that the accused is not guilty. Well, we failed to reject it, but this person really was a criminal. So the feel of this mistake is different. This is letting guilty people walk free. So in terms of the court system, this is where the innocent go to jail. The type 2 error is when the guilty go free. However, that's just for concept development. When we do stats problems, it's hardly ever in the context of a court of law. It's going to have other hypotheses. So this is just to kind of have something to hang these ideas on, something that most people are familiar with. Because even if you've never been in court and accused of something, you've probably watched a TV show or a YouTube video where people were accused of things. So, by the way, the power of a test, so far these are 1 proportion Z tests or a 2 proportion Z test. It's the probability of correctly rejecting a null hypothesis. So power is 1 minus beta. It's the probability of correctly rejecting a false null hypothesis. I mean, if it's correct, of course it was a false null hypothesis because you rejected. So, so the power is basically the probability that the system of judges and juries will come together and get guilty people in prison. So you want power to be as high, as close to 1 as possible. You know, a power of like 0.95, 0.97, that means that the guilty people are going to prison. That's what the power is. And effect size is the difference between P and P0. I have a diagram for you to look at so we can organize that. But so explaining the type 1, okay, we're going to explain type 1, type 2 errors in context. Actually, in the next lesson when we take a look at that. So let's just go to page 2. I actually do have the diagram here. So the diagram popped right up. This is actually kind of nice. Would you please, I'll draw it for you, and so that you don't have to just look at a whole diagram, but are there any blank sheets of paper on this? It looks like you have, find a blank half page. It looks like on page 3, there should be a blank half page. Here, I'll show you where that is. 15, nope. At the end of problem 17, there's enough room for you to write, and let's draw these diagrams. You have to draw 2 bell curves. One bell curve is centered at P sub 0, and let's imagine that the truth is not P sub 0. So let's put another bell curve horizontally down, and this one is centered at the truth. Okay, so this is highly theoretical because the truth is in the picture. Now, you're going to draw a vertical limbo bar, and the vertical limbo bar has to go through both tails, so like this. And this is labeled, I believe that's a P star. Yeah, P star. So this vertical limbo bar is going to be labeled P star. The critical P value, that's actually another use of P that we haven't seen before. Now, alpha is basically, it's where you set, you can think of it as alpha, but P star, right, equals alpha, the critical P value. Oh, I know why we're not using alpha, because alpha is what we used. Yeah. You can't say alpha because that's the same thing as this. So there's a reason we're using P star there. Just call it P star, critical P value. Now, alpha is the probability of a type 1 error. So, why would that be? Why would that be the probability of a type 1 error? Let's think about this. Instead of a court of law, let's think of this as the true proportion of dogs who bite people. And suppose we hypothesize 25%. So just think of 25% right here. And suppose that it's really 40%. It's really way up here. Well, there's going to be times when the, so type 1 error. Is type 1 error correctly rejecting or incorrectly rejecting the null hypothesis? Type 1 is correctly. It's a shorter. It's. I'm sorry. I asked the wrong question. I said correctly or incorrectly. I should have asked the question like this: Is it type 1 error the probability of incorrectly rejecting the null hypothesis, or the probability of incorrectly failing to reject the null hypothesis? Incorrectly rejecting. So, here's what's happening here. The null hypothesis is that P sub 0 is 0.25. The alternate hypothesis is that, not P sub 0, P equals P sub 0. So P equals 0.25. Here it's P is greater than 0.25. So type 1 means incorrectly rejecting the null hypothesis. So that means that we rejected the null hypothesis and concluded that it was greater than 0.25 when it was really 0.25, which means this graph is not in the picture yet. If that's gonna be a type 1 error, then that assumes that the null height, that this was the truth. This was the truth right there. If you find yourself, if the camera's in the way, move to a different seat so you can see. You don't wanna, you need to see this stuff. So, in a type 1 error, it's really 25% of dogs really do bite people, and this percent of the time we make a mistake. We reject the null hypothesis when it was really true. So this is like your alpha level. If you are uncomfortable with how many type 1 errors you're making, and you will make a percentage of type 1 errors, and you will make a percentage of type 2 errors in any court system, in any inference, when you're using statistics, you will make type 1 errors a certain percentage of the time, and you will make type 2 errors a certain percentage of the time. But if you don't like type 1 errors, you can move this bar down in your system. You can decrease alpha. But when you decrease alpha, guess what? This is beta. When you decrease alpha, you increase beta. So moving this line to the right will decrease type 1 errors, but it will increase beta, which is your type 2 errors. Or it's the probability of your type 2 errors. Okay, this is just a right tail. There's other diagrams we could draw for a left tail test or a two tail test. It's harder to conceptualize, but the basic ideas are the same. So power is the area of this region right here. Power is 1 minus beta. And effect size is the difference between P0 and P. The difference between P0 and the truth. So effect size can be seen right here. And Caleb, well, hey, do you want the paper notes?
I do.
Paper notes right there. So, in fact, there's more paper notes. That's because that's not the only lesson we're doing today. We're also doing 8.9. Let's find all the paper notes. And, okay, so I'm just gonna line them up over here. Here's all the paper notes you possibly want, if you're gonna be going for 8.9, 8.10, 8.11. Okay. All right, here we go. So this double bell curve diagram, we're gonna be using it a fair bit today. It contains alpha, probability of a type 1 error, beta, probability of a type 2 error, power, which is 1 minus beta, and effect size, which is the displacement, the horizontal displacement between P0 and P. All right, so back to the show. Let's take a look at, let's go in order here, at loans. So we're not in court of law here, we're just taking a look at loans, and the problem reads, before lending someone money, banks must decide whether they believe the applicant will repay the loan. One strategy used is a point system. Loan officers assess information about the applicant, totaling points and award the points for a person's income level, credit history, current debt burden, and so on. The higher the point total, the more evidence we have that it's safe to make a loan. Any applicant with a lower point total, lower than a certain cutoff score, is denied a loan. We can think of this decision as a hypothesis test with a null hypothesis, alternate hypothesis. Since the bank makes its profit from the interest collected on repaid loans, their null hypothesis is that the applicant will repay the loan. So just like in the court of law, the null hypothesis is that the person is honest. The alternate hypothesis is that honest when they say they're going to repay the loan. I will repay the loan, believe me. Should we believe them? The null hypothesis is that they are either a bad risk or they're dishonest. Okay. So, when a person defaults on a loan, which type of error did the bank make? You have to figure out, is that a type 1 or a type 2 error? So, those of you who were not here when I explained this, on the first page, a type 1 error, you might want to fill it in, a type 1 error is when you incorrectly reject the null hypothesis. That's alpha. And the type 2 error is when you incorrectly fail to reject the null hypothesis. So talk with someone nearby here. A person defaults on a loan. What defaults mean, by the way, is they say they're going to pay it back, but then they don't pay it back. That's called defaulting. Tell someone nearby, is that a type 1 or a type 2 error? So have at it, talk it up.
Well, what is defaulting again? Defaulting when you.
Defaulting is when you say you're going to pay it back, but then you don't.
Okay.
The incorrectly failed.
Oh, yeah.
You should know, this is the people with a high score. So use the high score. What's the null hypothesis? Well, so.
Okay, raise your hand if you're thinking, or you're leaning towards type 1. Anyone leaning towards type 1? Raise your hand if you're leaning towards type 2. Okay, so let's find out what's going on here. If the person defaulted, then that means that they were dishonest. That's the truth. But the fact that they defaulted means that the bank concluded they were honest, so they made a mistake. If they concluded they were honest, then did the bank reject the null hypothesis, or did they fail to reject the null hypothesis when they decided to give the loan? And that's a key thing you have to get to. They failed to reject. Otherwise, they wouldn't have given the loan in the first place. And once you know they failed to reject, and now we see that that was a mistake, they should have rejected the null hypothesis. Once you see fail to reject, you know it's type 2. Because type 2 always involves failing to reject the null hypothesis. Type 1 only applies to situations where the decision-making powers rejected the null hypothesis. Any questions on part A? Okay, in part B, what kind of error is it when the bank misses an opportunity to make a loan to someone who would have repaid it? Well, you don't really have to think about that, because why would they ask 2 type 2 error questions in a row? It's got to be type 1. But then when you actually think about it, because they don't always do it like this on quizzes, you say, okay, someone who they would have repaid it, oh, that means they're honest. But they didn't loan it to them, so they must have rejected the null hypothesis. This is a case where they rejected the null hypothesis, but it was a mistake. Mistaken rejection of the null hypothesis, that's what we mean by a type 1 error. Any questions on part B? Okay, now we're going to talk about moving the limbo bar. Suppose the bank decides to lower the cutoff score from 250 points. So you need at least 250 points to get a loan. What if they say, no, let's make it easier for people. If you get 200, these are like character points, the better, more honest you are, the more financially secure you are, the more points you get. You say, let's make it easier to give people loans. Let's say they only have to get to 200 points. Is that analogous to choosing the higher or lower value of alpha for the hypothesis test? So let's look at our little diagram here. Because we put the diagram on the next page. It's like, suppose it was set at 200 points. And when it was at 250 points, you had a certain probability of a type 1 error. Is changing the standard from the cutoff from 250 to 200, is that like moving the bar to the right, thus lowering alpha? Or is that like the bank saying, let's move the bar to the left? So to answer that question, you should try to figure out, well, what would the effect of changing the cutoff have on the probability of a type 1 error? Please talk about that one with someone nearby.
Yes, the diagram. So you have P zero, that's your lower bound. So then you have P. That's not P. Yeah, that's the actual. What is that? Just that's on the effect size. P zero. P. Yeah. Power is 1 minus beta. stars is like.
Here's how I recommend you get your mind around this. I mean, believe me, I know this stuff can be confusing. So here's how I would recommend you frame the question you're thinking. As a result of changing the cutoff score, again, if you got 800 points, that means, oh man, you're so honest, we're gonna give you the loan. So by changing it from 250 to 200, that could increase the probability of a certain kind of mistake. Does that mean that because of this change, that it's more likely that people will be mistakenly declared, what, is it honest or dishonest?
Honest.
Because we're lowering the standards, it's more likely that people will mistakenly be declared honest. And since honest is the null hypothesis, that means there's a higher probability of declaring people honest when they should have been declared what? Dishonest. So if you declared them honest, but it was a mistake, then you've got to ask yourself, is that mistakenly rejecting or mistakenly failing to reject? Raise your hand if you think you know what that is, because there's several steps to this thinking process. You make the first step just fine. You understood that making this change means it's more likely to make the mistake to conclude that people are honest when they're really dishonest, which means that it's more likely to mistakenly do what? Reject or fail to reject. Raise your hand if you think you know. Yes, Rachel. Yeah, it's more likely that you're going to make the mistake of failing to reject when you should have rejected. Okay, so failing to reject is always about type 2 errors. And so when you look at your diagram, look at the part of the diagram that has to do with type 2 errors. The part of the diagram that has to do with type 2 errors is beta. So if you're going to increase beta, that means that the bar, I mean, which way, if the green graph stays fixed and the blue graph stays fixed, and the only thing that moves is this bar and its corresponding areas, which way do I have to move this bar to increase beta? Beta's area. Class, right or left? If I move it left, beta will get smaller. If I move this to the right, alpha will get smaller, but beta's area will get bigger. Do you see that movement in the diagram?
Yeah.
Okay, so now let's see what they're asking. Now that we see that beta is going to increase as a result of that, how are they wording the question? See, by choosing, so there's a lot of links to that thinking. So because beta is going to get bigger, is alpha getting bigger or smaller? Yeah, wow, they are really checking to see if you understand this diagram. This diagram is huge, and for some of you it can be the difference between a 4 and a 5 on an AP test. Well, really, that's a silly thing to say, because any concept could be the difference between a 4 and a 5 on the AP test, but it's just kind of fun to say. It gets people's attention. So you told me that beta is going to get bigger, which automatically means the inverse relationship alpha is going to get smaller. Now, without that graph, without the two bell curves there, I would be lost on this problem. It's analogous to say, so we said higher alpha, it's lower. Higher beta means lower. So the bank has reduced the alpha level. How are they going to explain in just one sentence? Well, it takes, one way to explain it in one sentence is the evidence approach. It takes less evidence to grant the person the loan. Or you could explain it in terms of what we just did here in class. We said now it's more likely for them to be mistakenly declared honest, which means it's more likely to fail to reject the null hypothesis, which means beta increases, which means alpha decreases. And it's easier to come up with a long explanation. You might not be convinced by this super short explanation because it's like so short, it's like, wait a second, well, it's not an explanation. So I would recommend when you explain it, you want to be safe, you're saying, we increase the probability of mistakenly declare the person to be honest, which means we increase the probability of A failing to reject. And that means we increase the probability of beta, type 2 error, which is beta, which means we decrease alpha. That's the actual thinking there. Usually on the AP test for this, you don't have to explain your reasoning, you just have to be able to get the right multiple choice answer. Now, next question. What impact does this change in the cutoff value have on the chance of each type of error? So we already said that it's a good thing we analyze it like this. So increased beta, so type 1 error, which is alpha, is decreased. Yeah, because we put the time in to really reason this out up above in part C, now we can see clearly that we're decreasing alpha, which is type 1, and the risk of type 2 error has been increased. So I'm a big fan. I mean, personally, this is the diagram that helps me sort through all these complicated conceptual questions about type 1 and type 2 errors. Do you have any questions on this? Yes. Kevin.
You quickly explain what is meant by power and effect size.
Yeah, power is, by definition, the mathematical definition is 1 minus beta. In the court of law, and this was probably before you got here, but in the court of law, you know, the null hypothesis is that the person is not guilty. The alternate hypothesis is that they're guilty. So power in the court situation means the probability that we correctly reject the null hypothesis, which is the probability that we, you know, can stand up to the criminals and say, you're guilty, you're going to jail. That's what it feels like in the real world of the courtroom system. Effect size is just the difference between P and P sub 0, and that doesn't get a lot of play in this stats course. It gets more play in later stats courses, but just kind of building some foundational vocabulary. All right, let's move on to number 17, I believe it is, number 17. Second loan. In the context of this problem, number 17, what we mean by the power of the test is, and again, let's read it. Exercise 15 describes the loan method. Okay, only if the total points awarded for various aspects of the applicant's financial condition fail to add up to a minimum cutoff, will the loan be denied? So, what's meant by the power of the test? In a bank, in a court, we see it's, you know, the probability that we put the guilty in prison. What does it mean in the context of the bank? It means the probability, instead of putting guilty people in prison, we're saying no to dishonest people. Power is the probability that the bank denies a loan that could not have been repaid. So it has the same feel as putting guilty people in prison. Is there justice? Power means it's probability that justice occurred. What could the bank do to increase the power? Well, they could raise the cutoff score. But if you raise the cutoff score, there's, you know, you're not going to be having as many people default. But because of that bar, because when you increase one type of error, you decrease the other. So if you want to decrease your type 1 errors, that means you're increasing your type 2 errors. So the disadvantage is that if the bank raised the cutoff score, a larger number of trustworthy people would be denied. We're saying no to people who would have paid back. We could have made money off of this loan. So the bank would lose the opportunity to collect the interest on these loans. Alrighty. So these are concepts that can really be understood if you see it graphically with the vertical limbo bar and the dynamics of movement in that diagram. Any questions on this? Is there more on this handout, or are we ready? Oh, homeowners. All right, we can do this. I think, you know what? This looks like a nice to know, but not need. It's more practice with type 1, type 2. Tell you what, we need to get to the video clip. I'm going to just kind of like shoot this up here while I'm getting the video clip set up. If you want to take notes on this last one, just for the sake of completeness, then you can do that. But with the video clip, what I learned, do you remember that day that I showed a video clip, and then after the video clip, I was like trying to make my computer work, and things were going crazy, things were closing up. Some of you found it incredibly hilarious, which is totally understandable because it was comical to watch. Do you remember laughing at me? Yeah, so, so I realized that's what happens to my computer system when I switch from Promethean board to TV and then try to go back to Promethean board. So I'm gonna show the video clip up here, and so that the people listening by YouTube can hear the sound, I'm gonna hold the computer close to the microphone. It's gonna be weird sound system, but this, I'm gonna have to do this to get the speaker next to the microphone. And I've never tried this before. I've never attempted this move, but this is how much we care about making sure that people who are not here can really learn. So here we go. I'm now going to open up the video clip. This video clip is weird because it's a video of me teaching, and I'm going to be showing a video on the video. And the video is from the O.J. Simpson verdict. How many of you have heard of O.J. Simpson? Heard? Okay, now there's a Stevenson High School connection on this. I used to teach at Stevenson High School. Turns out that the night that Nicole Brown Simpson got killed, allegedly by O.J. Simpson, although he was not convicted of this. So, some people believe that O.J. Simpson is guilty, even though he was exonerated. Some people believe that he's not guilty. But the point is that the night that Nicole Brown Simpson died, Ron Goldman, who was with Nicole Brown Simpson, also got killed. Ron Goldman was a graduate of Stevenson High School. And so with the community that I come from, this is kind of like an intense emotional issue. So in this scene, in this video, part of this video was taken in terms of reaction from people around the world, people of different races reacting to this, some of whom thought that justice had been done, others of whom thought that it was an error. And that's the main reason I'm showing you this. I want to think, for the people who think that a mistake had been made, are they thinking that a type 1 error had been made or a type 2 error had been made? But the reaction shots are someone using their video camera, pointing their video camera at a TV. It's like, this is 1995, it's low tech. So I'm gonna show you a video of me making a video of a class in which I'm teaching, where the video clip comes up where you see a video of someone taking a video of a TV. So it's gonna be crazy stuff that you're gonna see in front of you. Let me get the lights. And that's borderline TMI, if you ask me. Okay, so your task as a student, your task is to figure out, for the people who are upset, are they upset because, even though they're not thinking type 1, type 2, is the error that they believe has been made, is it a type 1 error that they believe has been made, or is it because of a type 2 error? Now, interestingly, I have, so the 3-minute mark. Okay, so I'm gonna go to the 3-minute mark. I was actually, wait, hold on. Blu-ray player, well, this might work. I was not anticipating that message, but it might work just fine. It says I'm just using this app for the first time, which is a little bit of a surprise. But if M4V, okay. Well, oh, there it is. Okay, so it came up, and we're just going to go cancel on that, and it's working. Okay, so it's kind of working. What I'm going to do is go to the 3-minute mark. As you know, sometimes I take videotapes of myself when I'm teaching. Oh, okay, there's a clip. So this is the beginning of the clip, and I'm going to pull the sound up as high as I can on this and hold it up next to the speaker. This is, we'll go.
Wait, it's not all the way up on your board.
And let's put it all the way up here too. That, which
That's how it works.
which might be a big thing. Let's just get view full screen. Get the video. Fit to screen. Okay. And now, let's just do it, see where we're at sound-wise. That's pretty good. Okay, now I'm gonna hold it up here. Would someone, I don't know if I can do all this at once. Can someone come and help me hold these cables so I can put it right up next to the camera? Maybe, Jeffrey, do you mind doing that? Just, okay, this is the verdict. O.J. Simpson, you know, they got the DNA evidence. They had DNA evidence that seemed to put him at the scene. Here's a reading.
Simpson, would you please stand and face the jury? Mrs. Robertson.
Superior Court of California, County of Los Angeles, in the matter of the people of the state of California versus Orenthal James Simpson, case number BA097211. We, the jury, in the above entitled action, find the defendant Orenthal James Simpson not guilty of the crime of murder in violation of Penal Code Section 187A, a felony upon Nicole Brown Simpson, a human being, as charged in count 1 of the information. Superior Court of the State of California, County of Los Angeles, in the matter of the people of the State of California versus Orenthal James Simpson. We, the jury, in the above entitled action, find the defendant Orenthal James Simpson not guilty of the crime of murder in violation of Penal Code Section 187A, a felony upon Ronald Lyle Goldman, a human being, as charged in count 2 of the information. We, the jury, in the above entitled action, further find a special circumstance that the defendant, Orenthal James Simpson, has in this case been convicted of at least one crime of murder of the first degree and one or more crimes of murder of the first or second degree to be not true. Signed,
Those are the
this
parents
second
of
day
Ron
October
Goldman.
1995, juror 230. Ladies and gentlemen of the jury, is this your verdict? So say you one, so say you all.
All right, this time let's watch one more video where they show some reaction. I think the video on this next one, the quality of the video is a little bit shaky. I think someone was holding a video camera up to their television back in 1995. Take a look at some of the reactions here.
We, the jury, in the above entitled action, find the defendant, Orenthal James Simpson, not guilty of the crime of murder in violation of Penal Code Section 187A, a felony upon Nicole Brown Simpson, a human being, as charged in count 1 of the information. Superior Court of the State of California, County of Los Angeles, in the matter of the people of the State of California versus Orenthal James Simpson. We, the jury, in the above entitled action, find the defendant, Orenthal James Simpson, not guilty of the crime of murder in violation of Penal Code Section 187A, a felony upon Ronald Lyle Goldman, a human being, as charged in count 2 of the information. We, the jury, in the above entitled action, further find a special circumstance that the defendant, Orenthal James Simpson, has in this case been convicted of at least one crime of murder of the first degree and one or more crimes of murder of the first or second degree to be not true. Signed, this second day of October 1995, juror 230. Ladies and gentlemen.
Okay, so it seemed like there's a... All right, so let's put the lights on here. Thank you, Jeffrey. Appreciate that. So go ahead and talk about it. People who were upset, were they concerned that they thought an error had been made? Were they thinking type 1 or type 2? Go ahead and talk about it. All right, we'll go either one finger or two fingers. How many of you are thinking that the upset people thought a type 1 error had occurred? How many thought it was a type 2 error? Okay, so type 2, that would be incorrectly failing to reject. Let's see if that makes sense. Let's see. O.J. Simpson is presumed innocent. I guess the people who were upset, they wanted them to reject the null hypothesis and conclude that he was guilty. And they were concerned that they incorrectly failed to reject the null hypothesis. So that is in fact a type 2 error. So good thinking on that one. Any reaction or thoughts on the content itself? Obviously there's an emotionally charged situation there. How many of you have seen that video before, Bethany? You saw you've seen the O.J. Simpson verdicts. Okay, so some of you have. So, any thoughts or just any input on it? Reflections, perhaps, yes?
Where did you find the video of someone taking their video of the video?
It's on YouTube. And the video of the video, well, actually, I mean, I made a video of myself. So that, I mean, that one was just a video. How did I import that? I think actually, I just forget. I forget how that was put together. Any other comments or questions, reflections perhaps? Cultural dynamics. Okay, fair enough. We don't want to leave the point, but I just want to give you a chance to react if you wanted to. Tell you what, let's go to the 8.9 handout. So if you don't have the 8 points, well, do we just do that one? No, we have one yet. Okay, so come up and grab the 8.9 handout if you don't have that yet.
I got it, Josh.
Yeah, watch out the camera.
She says that Hackett isn't good luck. I don't know, that seems kind of dumb. What rich privileged school reaction can't go somewhere? Oh.
Why
does she want it?
Green. Yeah.
Later.
Oh.
She's going to chat.
She just like, why?
Alrighty, so here we go. We're rolling. And okay. Now, right at the top, you have an opportunity to review type 1, type 2 errors. So, up on the top of the 8.9 handout, go ahead and write the verbiage here for the type 1 and type 2 errors, just to kind of drive that home. In parentheses, that's just where you put alpha. So hopefully you wrote for type 1 error, probably been correctly rejecting null hypothesis, probably incorrectly failing to reject null hypothesis, that's bad. By the way, in the OJ video, the lack of celebration seems to indicate a concern that type of error has occurred. So you already answered that, you got type 2 for that. If you just want to watch the video that I watched as Google search terms, would be Frontline OJ Verdict Video YouTube. And in case you want to look at maybe a more extended video of that. Okay, so type 1 and type 2 errors can be tied into a two-way table. So let's bring up, I found this to be an incredibly helpful mathematical exercise to review what we've done in the past with, like all the way back to the Titanic two-way table. So let's imagine that we have a two-way table here, 2 rows, 2 columns. And let's calculate alpha and beta from a two-way table. We've never calculated alpha and beta off of a two-way table before. Suppose that you have a reality in which, in actuality, 10 people who were guilty were declared guilty, and 5 of the guilty people were declared not guilty. The actual guilt status here also is that there are 2 not guilty people who, and this is a scary thing, the 2 of the not guilty people were put behind bars. This is sending 2 innocent people were sent to prison, and 7 innocent people were not sent to prison, or whatever the consequences were, not given community service. So based on these givens, this is just given information, can you calculate alpha based on this table? give it a go. See if you can reason this out. What's the probability of alpha type 1 error? There's this remarkable opportunity to bring out the air gun, the hair dryer, right? Is that what we did? We had a hair dryer.
The shrink wrap.
Shrink wrap, and we called it a something gun, didn't we? No. Because that video that we watched of the guy using with the shrink wrap. Oh, heat gun, the heat gun, the heat gun. Yeah. Heat gun, not as dangerous as. All right, so let's take a look at this. Double check with fellow group members, see if you can come to a conclusion. In fraction form, what's the probability of alpha? Or what is alpha, the probability of a type 1 error? Okay. Who has an answer? Maybe you've reasoned it out and you think you know the fraction in reduced form, reduced fraction. Caleb? Okay, Caleb says 2/9. Please raise your hand if you agree with 2/9. People agree with 2/9. Here's the idea. Since a type 1 error is incorrectly rejecting the null hypothesis, that means it's a probability of a guilty verdict. Because if you reject the null hypothesis, you're saying you're guilty. What's the probability of guilty given that they're not guilty? So we shrink this down. We put shrink wrap on this. We shrink it down to the not guilty subuniverse. And we say, what's the probability that your jury verdict is guilty given that you are not guilty? That's 2 out of the 9 people who are not guilty. 2/9 is correct. That's your probability of alpha. Now, explanation of type 1 error in the context of type 1 error occurs when we conclude there is sufficient evidence that, and this is, by the way, let's not talk. This is not helpful for the conceptual goals that we have here, so you can cross it out. But type 1 error occurs when we conclude there is sufficient evidence that the accused is guilty in the context of court. When in reality, the accused is not guilty. The accused is not guilty. So, a type 1 error occurs when we send the innocent to prison. So let's just review what we talked about in the previous lesson. Send the innocent to prison, documenting some of our earlier discussion. So go ahead and check the two-way table and use a heat gun to try to find the probability of a type 2 error. So when you're done, you can look up here, see if we agree in reduced form. So I guess it happens 1/3 of the time. And here we shrink it down to this. It's a conditional probability. What's the probability of not guilty given that they're actually guilty? 5 out of 15. So explanation occurs when there is insufficient evidence that, cross off this goofiness, that the accused is guilty. That the accused is guilty when in reality the accused is not guilty. I'm sorry. Did I mess it up? Okay, type 2 error occurs. Type 2 error is incorrectly failing to reject the null hypothesis. There's insufficient evidence that the accused is guilty when in reality the accused is guilty. now has parallel construction. So, in context of the real world, this occurs when we set a guilty person free. And power is, can you calculate power from the table? Find the probability that the guilty people go to prison. Raise your hand if you think you have value of power. Should be a couple of different ways to get. You could get from the table, you can just take 1 minus 1/3, 1 minus 1/3 is 2/3. So just using the 1 minus beta formula, you can get 2/3. Or, what's the probability of guilty verdict, given that you are guilty, is 10 out of 15, so that's another way to see that's 2/3. Any questions on page 1? All right, let's go to page 2. Page 2 is the same table that I showed you back on the previous lesson. However, it's so jumbled together that no one can really ever understand what it means. You see, there is something that's really contributes to understanding when you separate the two bell curves out, because you can actually see what happens when you move the vertical limbo bar. But in this, came out of a textbook, they're trying to get the same thing across, but the two bell curves are on the same level. So it's almost impossible to understand. That's why I kind of, in the past, I've set up this in juxtaposition with that to show you that this diagram is much better than that one. But the bottom line is that we've already processed that. So let's just go to the next page. Equal opportunity. And, you know, as I look at this, what's meant by the power, we've covered these ideas. We've covered these ideas. But let's skip to number 29, which has some actual numbers in it. So we're on number 29 now. Jumping to 29. This will be good for you. Trust me. Okay. So we're talking about dropping out of stats. Who comes up with these things? 203 students signed up for a stats course in exercise 27. They use the software. There's this software that if you use this software, you'll get a really high score. You won't have to drop out. Then only 11 dropped out of the course. Okay. I do want to read number 27, just so that we get the context here. Let's go back and read problem 27, which, is there really a problem 27? Oh yeah, okay. So 29 is based on 27. Our stats professor observed that 13% of the students drop out. But the salesman says, look, try my software, and then the students will understand so much, and it'll cut the dropout rate from 13% down to something less than that. So, so that's what they're looking at in problem 27. In problem 29, this is what's happening. We're making it specific now. They used the software, and 11 dropped out of the course. Should the professor spend the money for the software? Well, basically, we have to do a hypothesis test. So this would be a typical example of a test problem. I've moved the test back to Thursday of next week. On the test, they give you this thing up here, and the rest of the page would be blank, and you'd have to fill the page with hypotheses, model, mechanics, conclusion. No. So, null hypothesis is that, instead of saying that the person at OJ is innocent, the null hypothesis is that the dropout rate does not change. Nothing's going on here. But the alternate hypothesis is that the software actually works. That the true proportion, the true dropout proportion is now less than 0.13 now that we've treated the students with this software. So we have to check conditions and all that stuff. And you've checked conditions before, you know the routine. So we're not gonna make a big deal about that. But down here, your version of the handout, it's filled in. It's almost all filled in. I want to discuss it with you though. Remember what you'd be doing, you'd have to get, the mean is 0.13, that's the hypothesized mean. do square root of, make those P0, Q0 over N to get the standard deviation. We're gonna run a one proportion Z-test, and it's a one tail, one proportion Z-test. It happens to be a left tail, because look, oh, with the software, only 5.4% dropped out. Is that a statistically significant result, is the question. Well, you have to get a p-value, and when you do all the mechanics and the model, put 4 numbers on the bell curve, you do get a p-value that's tiny. Look at that person is good at dancing the limbo. They're gonna easily make it under the limbo bar. And think a little bit about what the interpretation of that is. See if you can do it on the fly. If I were to call on you randomly to interpret point 0007, what would you say the interpretation of that is? Think about it so that if I call on you, you'll be able to give the interpretation of point 0007 on the fly. First, I'll take a volunteer. Does anyone think they can interpret that on the fly? Tell me what the p-value means in the context of dropping out of stats. It's a good exercise. All right, Caleb, go for it.
Right. Since the p-value of 0.007 is very low.
Okay, now thank you for saying that, because that's the same mistake that students make on the test. When I ask for an interpretation of a p-value, they often give me the conclusion to the test instead. Now, before you say what you just said, which is a conclusion, it's a good idea to think about the p-value interpretation just to make sure that your head's in the game. But that's not you've confused the interpretation of the p-value with the conclusion that we draw because of the p-value. So shift into a different gear. Are you or anyone else willing to attempt the interpretation, which has, the eyeball? Jeffrey, you want to give it a go? Okay, go ahead.
Yeah. Probability is 0007 that we observe a rate of statistic students that drop out of stats of
Basically 5.4%.
5.4% or lower due to natural sampling variation alone of samples of the same size, given that the actual proportion of students who drop out of stats is 0.13.
It's 13%, yeah. Yeah, that's exactly it. That's the interpretation. In case you didn't hear that on film, what Jeffrey said is that the probability that we observe, the probability is 0.0007 that we observe a proportion of students who drop out of stats of 5.4% or lower due to natural sampling variation alone in samples of the same size. Given that in reality, it's still 13%. I mean, whoa, that's really unlikely that we would observe 5.4% or lower. Given that it's really, natural sampling variation could do that, but it's very unlikely. What's much more likely is that it's much more likely that the software actually works. So we should reject the null hypothesis and conclude that the true proportion of students, and that's the only thing you put in there is that you might have been able to talk about the fact that these are students who have been exposed to the software. So the best thing to say here is that the best conclusion, it might be an error, it might be type 1 error, but the best conclusion would be that the software really does work. So that's what Kayla was about to say, is that since the p-value is so low, less than 0.05, we reject the null hypothesis. We conclude that there's sufficient evidence that the software really does work, that the probability of proportion with the software is really less than 0.13. And the third sentence would be not something like next Thursday she's going to die. The third sentence would be, we should buy the software and make students use it whether they want to or not. All right. So anyway, since p-value is very low, we reject the null hypothesis. There's strong evidence of the dropout. And as long as the professor feels confident that this class of stats is representative of all potential students, he should buy this. So they actually put in the third sentence here. This is the next Thursday she's going to die analog. So any questions on that one? So we just wrapped up that handout. Now let's go to, wow, we are moving through the handouts. So I guess we better hit 8.10. Where's the 8.10 handout? Some of you are wondering that, Michelle, but I found it. Here's the 8.10 handout. It's just one sheet of paper. So come and get the 8.10 handout. While you're up here, why don't you grab the 8.11 handout? Yeah, go for it. Thank you.
It's cold one, just have one in a while.
Okay. Now, the new formulas are basically row 2 of the AB80 sheet. And we already filled in row 2 of the AB80 sheet, so that should be done. If you were not here the day we filled in row 2 of the AB80 sheet, then I'll make sure that I post that online, but we're just gonna be going through it. So let's just actually do an example of this. So we're in 8.10, and this is where the null hypothesis has to do with the different proportions of two different groups. And you know what? What's the true difference in proportions? I am gonna pull up the AB80 sheet just so that I can refer to it. AB80.
Mr. Roy,
Yeah.
I used to Bob.
Well, you know, this is on YouTube and everything. You know, maybe say yes. Oops. Okay, so the AB80 sheet is row 2. Out of curiosity, how many of you were not here when we filled in row 2 of the AB80? So that's another thing you missed. Rachel, that's right. So sorry to put you on the spot earlier, so let's go fill in. So you might be able to fill this in on the fly. But the second row of the AB80 sheet, just so you know, this is where we are zooming, either building a D trap. We built P traps before, but in a D trap, you try to trap the true difference, P1 minus P2, the true difference. So in a D trap, where D is P1 minus P2, it's usually a capital D, by the way. We take the observed difference in proportions plus or minus Z star times, and here's yogurt day, Rachel. This is the variance for the first sample plus the variance for the second sample. So variances add even when we're subtracting. So what's a real world situation in which that formula would come into play? And I know that's going quickly, but you know, you can school help with that more. So here's a situation where we would actually use that. Let's take a look at the bottom, or would we? Yikes. Okay. It says 886 randomly sampled teens were asked which of several personal items of information they thought it's okay to share with someone they just met. 44% said it was okay to share their email addresses. This is somebody you just met, friends. 29% said they would give out their cell phone numbers. What's going on? A researcher claims that two proportion Z-test could tell whether there's a real difference among all the teens. Well, here's the problem. We're just checking to see if you're in checking conditions, because that would not, cannot use a two proportion Z-test because of IGA. The assumptions on the left, independent groups assumption. It's got to be two different populations. It's not appropriate since the responses are not from independent groups. They're from the same individuals. Independent samples conditions has been violated. So the independent group's assumption is justified when you meet the independent samples condition. So you just have to make sure that we're sampling from different groups. Like we can't take one sample of Wheaton Academy students and then look at two percentages in there. No, we'd have to sample from Wheaton Academy, and then another sample from Stevenson High School, and we can say, you know, what's the proportion, what's the difference in proportion of Wheaton Academy students and Stevenson students who think that it's okay to give away your cell phone the first time you meet someone? So maybe it looks like, well, Wheaton Academy in our sample was 10%, Stevenson High School was 80%. So the difference between them was 70%. So is that a statistically significant difference? The null hypothesis is that the difference is 0. We're going to assume there's no difference. and then we're gonna get a p-value based on the observation. So how would that actually roll? Here's how it actually rolls. Here's where you can legitimately do this. Dogs and cats that bite people on a particular planet inhabited by humans. Authorities believe that the proportion of dogs that bite humans is equal to the proportion of cats that bite humans. Researchers contacted more than 25,000 humans in 2 independent random samples. These are independent of each other. It's like, maybe like one were in one continent, Asia, and then another one was Africa. I don't know. They're independent random samples. They're not the same. They're certainly not all from the same high school. Got it? All right, so see if they've been bitten by a particular animal. Now, turns out that 11,169, about 88.1% of the 12,000 humans had been bitten by a dog. So 88% of the sample had been bitten by dogs. 84.9% of a different sample had indicated that a cat had attacked and bitten them. This is terrible. This is almost as upsetting as, okay, and then are the assumptions necessary? Okay, so we got randomization condition. The random samples are independent samples condition. This is a new one. You've never seen this one before, but both samples were drawn independently of each other. So 10% condition has to be done for both, and success failure has to be done for both. Now, creating 95% confidence interval for the difference in graduation rates. What, okay.
Wow.
What happened there? No, it's not for the difference in graduation, it's the difference in bite rates between dogs and cats, okay? So it's bite rates. That's, woo, okay. It's between these two groups. And so I think everything else is the same. That's just a contextual snafu that we just encountered there. But this is just our first chance to see how the formula is used. It looks like it's an observed difference in proportions of about 5%. And then when you fill in all the numbers, you don't do any of this by hand. You have to do the setup by hand, but to build the D-trap, you go to the calculator. So let's go to the calculator now and use the calculator to build the D-trap. So we're gonna hit stat test. And this is where the AB80 jingle comes in. We start by singing. AB80 5624 CD, donate your card today. When you look at the table in your imagination, as long as you have this in your head, P1 minus P2, mu1 minus mu2, then you'll be able to interpret the jingle. AB80 5624. Which side is the traps? And okay, are the traps on the left or the right, class? Traps are on the left, so if you want to build a D trap, then you do stat test B. So let's go to stat test B, hit alpha B, and let's type in the numbers. Okay, so here we go. X1, N1 will be for dogs, X2, N2 will be for cats. Type in the numbers that are in the problem and let's build the trap. Oh, 678. So for cats, 10, 578 out of 12,460. And we said 95% confidence interval, so 0.95. Calculate, that gives us the teeth. Let's see if it matches up with what is in the notes. It's, so the interpretation here is that we're 95% confident that the true difference in the proportion of cats who bite people and the proportion of dogs who bite people is between 2 and 4%. So it was 88% of dogs bite people in the sample, about 85%. So it's about a 3% difference. So it's like the difference between them is in the middle. The verbiage on interpreting this requires skill with the English language. So listen carefully to the interpretation. Based on this sample, we are 95% confident that the difference in the proportion of dogs who bite people and cats who bite people is between 2.3 and 4%, 2.4 and 4%. Now, and in your interpretation, there should be an indication of whether we're taking dogs minus cats or cats minus dogs. So, and that's one thing I left out of the interpretation. After I finished the interpretation, I realized it's not an E, it's a P. I just gave myself a P for the one I just gave you. So, in order to get direction of subtraction in there, I have to use the word more or the word less. So, here's my full credit attempt at interpreting this. Based on the sample, I'm 95% confident that the proportion of dogs who bite people is between 2.4% and 4% more than the proportion of cats who bite people. If these had been negative numbers, I would have used less. But the direction of subtraction in the problem is dogs minus cats. So teeth that come out positive would yield the word more. Teeth that come out negative would yield the word, or be connected to the word less. So because it's dog minus cats, and these are positive numbers, and I'll say it again, so you can write down whatever you want. I mean, most of it is just standard script based on the sample. We're 95% confident that the proportion of, first one, dogs who bite people is between 2.3 and 4% more than the proportion of cats who bite people. Now, the key thing is that what number is not between the teeth? What's the key number when you're building a D-trap? Does anyone know what it is? You can call it out. You can call it out. What's the hypothesized difference? It's 0. So if one's negative, one's positive, then you fail to reject the null hypothesis, basically. But since 0 is not between the teeth, then this is a statistically significant result. It's like, wow, it's really true that the difference in proportions is not equal to 0. So here's how we interpret it. By the way, more than, higher than the proportion of people bitten by cats. So that's the interpretation, higher than. Does it provide strong evidence? We say yes, because the interval does not contain 0. That's when you build these D-traps, that's the main issue, is does the interval, does the trap contain 0? Okay, now for the last handout. So grab the last one. Oh, you already have it. Okay, 8.11. Teen smoking. Yeah, well, I picked this problem because I know so many who smoke. So very well, it's time to confront this. Teen smoking. All right, so last one. Open teen smoking. And it's time to have a heart-to-heart about the effect of smoking on your heart. Okay. Yeah. I'm embarrassed at the extent, the steps that these textbook authors go to trick you into paying attention to statistics. So, oh, look at that. Jack, Prophet Jack, hey Jack. So, 5 traps. 8.11, teen smoking, part 1. Is that the Vermont study? Ha! Check that out. Okay, just fill in the hypotheses. Last one, you didn't have to fill in the hypotheses very much. But on this one, and I think this looks a little bit different than the format on yours, but it's the same content, right? Write the appropriate hypotheses. Are most of yours filled in?
They're all filled in.
Oh, they're all filled in. Okay, that's probably because we spent so much time watching the Prophet Jack video. We didn't have time. Okay, so if it's all filled in, then That's good. We'll just talk about it, because we don't have much time anyway. Write the appropriate hypotheses. The null hypothesis is that the two proportions are the same. And what is this? The context here is 284 students indicated that their parents disapproved. So when your parents disapprove, 54 of them became established smokers. Of the 41 students who said their parents were lenient about smoking, only 11 became. So it doesn't really matter whether parents say don't smoke. We're going to assume that the proportion from disapproving parents and the proportion of kids who smoke from lenient parents is 0, or the difference in proportions is 0. And notice that the alternate hypothesis is that disapproval minus lenient would go negative. Yeah, so if you disapprove, that should make this proportion lower. So we're assuming that parental influence actually has a positive effect as opposed to a backfiring. I mean, in the industry, out in the real world, they usually make the alternate hypothesis with a does not equal to symbol, because for parents being against smoking, you never know what that's going to do. It could lower the smoking rates in the kids, or it could backfire. It could make them want to smoke more. So you don't really have a basis for saying less than, but this is an optimistic view of human authority, parental authority. So anyway, so this is just another example of how to set this up. But this time we're going, isn't that interesting? This is we talked about pooling, and Rachel, that's one thing you missed, but the pooled proportions, this is our first example of doing stat test AB 8056, stat test 6. This is where the pooling is involved, because we're assuming there's no difference between the two. So we have to pool them together, and you do have the rest of the notes filled in, or is there something to fill in?
There's some.
Is it on this page or the previous page?
This page.
That's what I thought, on this page. So that ties back into type 1 and type 2 errors. That's D, A, B, C, D. But also, part D, A, B, C. D is right there. It says explain in context. So that's pretty straightforward, but notice that the observed difference is the number that goes right there on the bell curve. So we'll, I have a practice test I want you to take with you. So before you run away.
Kellen Smith, Rylan Hershey, please see Mrs. Hess in the library before you leave school. These students, please stop by the front office. Max Amlicker, Kelsey Benware, Josh Brunner, Mia Reinbrandt, Sam Tijerina, Masa Kasai, Jack Andrews, Amy Sellers, and Jack Ryken. Please stop by the front office before you leave school.
Gonzaga is tied with UNC? Are you?
Seriously?
They're tied. 58. There we go.
What's the
Homeworks 3 and 4 are due on Tuesday. Wait, hey Josh, do you have your attention? 3 and 4 are due on Tuesday. Do this practice test also.
That was 38 minutes ago, so it's probably over. So as soon as I connect
I'm gonna practice test. But we wouldn't be able to take it.
I love Gonzaga. I
I
don't
don't
know
have the practice test, we go over it before you take it. Because Tuesday.
Oklahoma lost.
Yeah.
I was so mad.
Gonzaga won?
Wait, what's the score?
They were tied 860.
Oh my god.
Oh, yeah, that was a close guy.
See,
They're
it's such
tied
a close
today.
game.
Like, who expects so much
I'm
more?
so mad.
So,
Oklahoma
Well, I remember Kansas is getting a second round crop. I think it's second round. So
Who do you have winning this year?
Who do I have winning? And Xavier. I both want a little more outside brackets because they're both in like a pretty big size.
So yeah, we'll try to get you some practice tests through email or something. We'll figure that out.